As you see from my title, I'm going to thematize computer game space and how we orient ourselves in this kind of space or these kinds of spaces. And part of my motivation for my talk is that a lot of discussions concerning space and spatial orientation are merely focused on spatiality as such and not so much on the directionality of space, so I will focus on that in my talk. I will start with a reference to Espen from his article from 2007, Allegories of Space, where he claims that computer games, that spatiality plays a primary role in computer games since computer games are, citation, essentially concerned with spatial representation and negotiation. I subscribe to the assumption that spatiality plays an essential role in computer games. I will argue, however, that spatiality as such does not serve a primary role in computer games. So in my paper, I have three main theses which are combined. And the first is that directionality plays a primary role in spatial orientation. The second thesis is that we, or I, as I play as an avatar, have a mental capacity or power that enables us to differentiate between directions in space. And the third thesis, 1 and 2, are properties that are necessary conditions for the possibility of spatial orientation, both in virtual and real or physical spaces. My directionality analysis is a novel approach to the problem of spatiality and spatial navigation in computer games, in that it gives an analysis of a common basis for spatial orientation both in virtual and physical space. The way spatiality normally appears in computer games is through the perspective or the view of the avatar, either from a first-person perspective or from a detached third-person perspective. It is often argued then that spatiality in computer games is invisible or appears as an as-if spatiality to the perceiver or the avatar. One of the implicatures of such a view on game space is that normal or physical space is taken to be something visible and real. It turns out, however, that the conception of real space is often conflated with the conception of physical space. In what follows, I will clarify some of these conceptions in order to get to terms with what the differences between them are and in order to show how they are related. So I will now look a little bit into space as virtual, space as physical, and space as real. A game space is said to appear as virtual, first and foremost due to its non-physical appearance. That is, due to its lack of, among other things, gravity and impenetrability, in addition to exhibiting a primary visual depiction of depth, three-dimensionality. I regard these as some of the most essential property of virtual space that distinguishes it from its physical counterpart. One of the main problems with this conception of a game space is that it emphasizes the visual as that which constitutes spatiality. And as a consequence, spatial orientation is explained primarily by reference to movements in relation to visual signs, marks, and virtual objects. This way of explaining spatial orientation echoes the Leibnizian relational theory of space and time, where space is thought to exist only as a relation between objects. On this view, space does not have an existence independently of those objects. Space is here accounted for in purely logical or mathematical terms, where spatial relations and directional oppositions are treated as relations in a logical space. In what follows, I will argue that such a logical conception of space, which is attached with its attached logical condition for spatial orientation, does not allow for an account of directionality as such, since directionality within this logical relational picture of space is a result of an abstraction from a relation between objects in space. Instead, we need a conception of space as real, where real space is a condition for orientation both in virtual and physical space. But what about games that challenge spatiality and orientation as such? That is, games that don't focus on objects primarily or the visual tokens or marks, but games that play with our capacity for orientation as such. Do they challenge the relational view on space in that they do to a greater extent explicate the system of directionality as such and not the visual objects in space? One example of such a game is Portal, which many people have discussed already, but we find several others like, for instance, Antechamber, playing with the laws of nature, wandering through non-Euclidean spaces, and Fez, playing with different dimensionalities from 2D and upwards to multidimensionality. This latter game echoes Flatland to a certain extent, as I see it, the famous book. Okay, so now I will continue with some remarks on our capacity for navigating in multidimensional game spaces. From the example of the different game spaces above, some versions of computer games can be used in order to display different spatial structures as such, like these games. For instance, multidimensionality, hyperspaces, and the like. I mentioned the computer game Portal as an example of such a game, and in this game, the avatar navigates in multidimensional spaces, where it moves, for instance, in and out of different wormholes. And a wormhole, also known as an Einstein-Rosen bridge, is a hypothetical topological feature of space-time, and a topological feature is very often a part or subset of this logical space, or this mathematical conception of space, so we can discuss that. Within a general theory of relativity, that would be fundamentally a shortcut through space-time, that is, moving from one point in space to another without crossing space between. Wormholes are primarily an unvisualizable structure existing in 4 or more dimensions. Interestingly, the game Portal sets out to visualize this unvisualizable thought experiment from physics. And there is an interesting interview with physicists at the University of Nottingham working with multidimensionality and hyperdimensions, and they comment on to what extent Portal is a game that is able to visualize what they work with mathematically. And the short conclusion from that interview is that they say that Portal gives them an interesting insight into how you might develop your intuition for navigating in non-Euclidean spaces, but simultaneously they emphasize that it's not under any condition possible to visualize this, for instance, wormholes properly, even if you kind of feel you do that in this Portal space, or in the space in the game Portal. But it's an interesting interview because it says a little bit about what games can do in order to shed light on not only physics or mathematics in general, but on this dimensionality problem. So does this play with the avatar in multidimensional space indicate that when acting via this avatar in a computer game, we are able to interact with and orient ourselves in these multidimensional spaces and wormholes? As I said, these physicists said kind of yes and no, and I second them on that. I say yes and no. The game Portal exemplifies such a possibility, but what exactly do we do when we orient ourselves in this game space? In order to answer the question, I will look into our capacity for orientation and how it is related to the system of directions. Since the avatar plays the game on behalf of a human being, the capacity for orientation of the human being should consequently be regarded as a relevant departure point for the analysis. So, on directionality and our capacity for spatial orientations. As human beings, we have a mental capacity or power that enables us to differentiate between directions in space. This capacity for orientation is an effort of the mind of which we are conscious through a feeling, and this feeling is not a normal, sensible feeling like the sensitivity we have from the receptivity of the normal senses. It's another kind of inner feeling, and this representation is nor a discursive thought or representative of discursive thinking or conceptual definition of this power. So in the following, I'll consider some of Immanuel Kant's arguments in his work Attempt to Introduce the Concept of Negative Magnitudes in Philosophy, which I hereafter refer to as negative magnitudes, from 1763, in order to clarify the conception of the direction in this context. In this work, Kant gives, among other things, an analysis of the status of the real in contrast to the logical. So here we have this split between the real and the logical. And he is arguing about real oppositions and of the real ground for these oppositions and of the unanalyzable primitive concepts of this real ground. He's also talking about this inner feeling of oppositions in that connection, this feeling which was neither a result of the receptivity of the senses nor from the discursive concepts. This analysis represents an alternative to the Leibnizian relational conception of space that I touched upon above. In the negative magnitudes, Kant argues that realities, of which a real ground is an example, are negative magnitudes and as such they stand in the relation of real opposition. So what then is a negative magnitude? Kant answers the question as follows. A magnitude is, relative to another magnitude, negative insofar as it can only be combined with it by means of oppositions. In other words, it can only be combined with it so that the one magnitude cancels as much in the other as is equal to itself. That the magnitude is negative implies that it is combined with another one in opposition. And where are we heading with this directionality problem here? You can by yourself think about the example of the distinction between left and right, or up and down, or back and forth. This does not mean that the magnitude itself is negative, but rather the opposite. It is positive. Kant unambiguously states that each of the magnitudes that are involved in real opposition is something positive. That is, the one magnitude is not a logical negation of the other, as it is in the Leibnizian scheme of explanation. Further in the same work, and just some sentences after the citation you have in front of you, Kant also emphasizes that it is only when the former magnitude is combined with the latter magnitude that it contains the ground of negation. So what does that mean? It means that he argues for a system of oppositions where you can't argue for one of the parts of that system without the other. And my implicit argument here on behalf of Kant is that, for instance, the direction left and right, these directions, are standing in this kind of a negative magnitude oppositional relation. So by applying the name negative to the magnitudes involved in this relation, Kant also sets out to designate that they are real opposites. That means that they can't be reduced to the logical ones or to purely empirical relations between objects, for instance, like saying that you, in a case where you would consider the right hand an object in contrast to the left, for instance. So it's not an objectified conception of opposition here. It's this kind of from the inside out system of relation between the opposites, and in that sense these opposites are real and not physical or mathematical. If you look then at Kant's example of our hands as incongruent counterparts in his famous work concerning the ultimate ground of the differentiation of directions in space from 1768, 5 years after that first work, he argues that the left and the right hand stand in a reciprocal relation, that is a real opposition. So the direction left stands in a real opposition to the position right in the sense that a purely logical negation of left does not necessarily give right. Instead, we move from the left to the right, where left is still something positive, but in the change of movement towards the opposite directionality, direction right is now cancelled out. Direction right is now cancelling out direction left as a result of the opposite motion. So left is still something positive that is cancelled out by the movement in that opposite right direction. So you see, even if you focus the movement to the right, you still have the left in focus in the sense that you understand that rightness is the total opposite or directionality. Interestingly enough, Kant argues that the real opposition occurs when two predicates of a thing are opposed to each other, but not through the law of contradiction. So he emphasizes that clearly that this is not a contradictory relation. So from this we see that negative magnitudes concern properties of objects and not the objects themselves. So we have another argument that supports the anti-objective orientation for directionality. So this coincides with Kant's discussion of directions like left and right in these directions, where he argues that they are spatial properties and not objects. Another similarity is Kant's between the arguments in these two works, between right and left, and the oppositional structure, is that these directions don't represent a logical but a real opposition. So this is the common argument. From the analysis we have above, we see that there is a possibility of considering the different directions as negative magnitudes in this sense, and that the reciprocal relation exhibits a real opposition, not a physical one, not a mathematical or logical one. Further, in a real opposition, the determination which conflict with each other, like left and right, we can't be both at left and right simultaneously, must exist in the same subject. And in this case, the subject is a prerequisite for this real opposition to be possible. In addition, when we measure this motion from one direction to the other, Kant says that they are exhibiting these magnitudes as intensive magnitudes. That is, we don't add them externally as units or entities next to each other or after each other. They are intensive magnitudes in the sense that they are measured in degrees. And Kant himself uses an example like force or power, since force is measured intensively. The parts of a force does not stand in an external relation to another part of the force. It's a continuous line. So according to Kant, then, the same goes for directions. They are having this kind of property of a force or a power. So the further to the left you move, for instance, the less to the right you are positioned, seen from the agent's or the avatar's eventually vantage points. So properties like, for instance, leftness of intensive magnitudes are measured intensively in the sense that each property is not considered an external part vis-à-vis the other unity. So, seen on the background of this analysis, our capacity for spatial orientation can neither be derived from a representation or relation between objects or marks in space, as a spatial relationalist would claim, nor is it derived from any logical or mathematical definitions of spatial relations and configurations. In other words, our capacity for differentiating directions is a capacity to relate spatial directions as real and not logical or sensibly relational. Reciprocal relations. One of the implications of this is that the absence of a spatial direction does not represent a purely logical negation of the other direction. Instead, it is always present there as something, as we saw, not a not left, for instance, if you are in the direction right. I have presented now an analysis that may be described as an analysis of a proto-proprioceptive capacity exhibited through the exercise of our mental powers upon our spatial environment, in the sense that the way we understand this oppositional structure of these directions is through a inner force that is caused by our bodily configuration. Kant is applying the concept self-affection in this context, that when the body gives the signal back concerning its oppositional structure, we are self-affected by this, and it causes a inner feeling of this bodily configuration, and it is that inner feeling, which was not, as I say, a feeling of the senses in the conventional sense, that gives us the orientational point for direction, the structure of directions in not only in Euclidean space, but also in non-Euclidean spaces. So for Kantier, it's not possible to reduce this directionality to a reference back to a body schema like you find in phenomenology, for instance. It's a deeper kind of analysis, therefore I call it a kind of a proto-proprioceptive analysis, where you have to go from this force approach to the oppositional structure that that force is exhibiting. So due to this basic structure, we are always primarily embedded in a three-dimensional Euclidean space, even if we try to step into other kinds of spaces, and our spatial perspectives are conditioned by that. From this it follows, among other things, that when we are situated in non-Euclidean spaces, we will continue to orient ourselves on the basis of this three-dimensional Euclidean scheme of orientation. So when orienting ourselves in, for instance, in the game Portal, we have to draw on our fundamental axis of orientation in the sense that we immediately perform sequential cuts and mappings, bits by bits, in order to interpret the surroundings as spatially meaningful or orientable as such for us. So, I have argued now that there is a real basis for our capacity for spatial orientation and directionality. That is, it's not physical and it's not mathematical or logical. So in that sense, it encompasses both of them in the sense of being the condition for the possibility of orientation both in physical space and mathematical spaces. And that these capacities and exercising of powers, establishing this oppositional structure that exhibit a whole system of directions. First and foremost, the Euclidean directions left, right, up, down, and back and forth. And the vantage point is always ourselves or the way we play through the avatar as an origo. And since this is not a primarily bodily explanation, this power-based capacity for orientation and directionality is kind of cognitively embedded in us in the sense that when we step into virtual spaces or game spaces or other kind of non-Euclidean environments, we are still having these axes with us. Thank you.
Yes, it's on. Okay.
Thanks a lot, Anita. And I appreciate very much the clarification of the concept of the real, to say that this is not the opposition to the virtual, but it's something that encompasses the virtual and the physical. Still, I believe that there are various ideas of what a real space then could be, but this is this is actually my point, so this would be the deviation, because I think you're talking about something that probably you would call also primitives. You used that in the discussion, and I think they are very much subjective primitives. Hence the directions reaching out from this point zero of the body in space. And I think they're also objective primitives, and I don't know which one is prior. I'm referring to a text that was written in 1799 by Herder. The meta-critique of the critique of pure reason was his revenge on Kant, where he said it's not so much, space is not so much about the predicates or the left and right thing, but about prepositions like in, out, on, by, through. And these are objective primitives, I think it would be in your wordings. And I don't know if we can find an agreement on which one is more basic. And I think I would have to agree that even these objective primitives some way imply experience or the body. But I think they still are there when it comes to space. And even, especially if we now look at computer games and turn away from first-person or third-person games, or maybe early computer games where you just have a situation in which the thing you might be able to navigate and it's not yet identified and there are other objects, they are more in this kind of a topological relation which is defined by prepositions, but not so much by directions in the first place. So this would be my with Herder against Kant, at least accept that there's also an objective basis for space, which is more Leibnizian maybe.
Yeah, it's. I agree that it's a subjective primitive, but it's a subjective primitive in an objective with an objective validity, in the sense that if this was purely subjective primitives, the system of directionalities, then you would not be able to, for instance, map different orientations from, let's say, you understand a third person's perspective, like the cup is to the right of you for me, but it's to the left of you for you. If you were totally immersed in a subjective system of coordinates without any objective validity, we would be immersed in that first-person perspective without that capacity for mapping and translation. So that is one thing, that this subjective primitive has objective validity, but I disagree that you also have an objective primitive, and especially that would be explicated through prepositions, like on and under, etc. Because in order to know what on and under and next to, etc. is, you already draw on these basic structures of oppositions that you carry around with yourself. Because the onness is not related to anything as long as you can't relate them back to that system of axes, which you kind of carry yourself as subjective primitives.
I have two questions. The first concerns the nature of the consequences for space that falls from this directionality capacity thesis, and the other concerns the consequences for space in computer games. I didn't quite follow the subjective-objective discussion, but it might be related. I'm not a Kantian. So my question is, I take it that the directionality, the capacity for directionality, which you talk about, it's supposed to exhibit Euclidean features, right? Yes. So what if, and a sort of counter argument perhaps, suppose that something were not counterfactual but counteractual. Suppose that the actual space, physical space as described by physics, were non-Euclidean. Wouldn't then the capacity for spatial orientation also be non-Euclidean? If that follows, it seems to me to then the capacity for spatial orientation would have to be subjective and not objective. Okay, perhaps that was one question. Another, I sort of trying to. I think it sort of implies an idealism about space of a sort, and so I'm trying to question that thesis. Then there is a question of computer games, because we have this very interesting thesis of directionality as a basis for orientation. I think, suppose you have this view, you move around in Doom, for example, back and forth and stuff like that, and you can report that I move to the left, I move forward with speed, stuff like that. And one view of that report is that it reports a fictional truth. It is literally false that I move forward, for example. So I would like to, given your perspective, how would you answer that question? Is it true or false that I move forward in Doom?
To your latter question first, I think it's a real movement, also in the game, and that's part of the reason why I also criticize this orientation towards the visual and the relational structure between objects, because you might imagine a blind person, for instance, or a kind of space even in games that is kind of empty, but as long as you have the capacity or the possibility in this case to move, let's say move forward as your example, you are moving in that sense. What you do then in the game, since you don't put your whole body in, is that you are using this embedded structure of directionality mentally. But that structure is, as I say, a consequence of being caused self-affectionately from the basic bodily structure. And then we are maybe back to the first question, which is that, okay, where do we get that one from? Because it's I mean, of course, this has been discussed in this context, that what happened if we grew up, let's say, we start with a human being. Let's say we grow up in a non-Euclidean space. There is no gravity. We go upside down eventually. I mean, we can twist a lot of these known figures. And of course, that would affect the way we orient ourselves. Other than, as long as you have a body, you will still have this axis of opposition. And this directionality analysis emphasizes that there is a necessary structure with this kind of duality, where you have this real oppositional structure in all directions. Euclidean, I would say that it would follow this fundamental system of the 6 directions. I mean, up, down, right, left, and back, front. But you could eventually think that you were walking on your head, or relating to the outer space, the so-called absolute space, in other ways. But as long as you have the body structure you have, that would mainly keep the oppositional structure, at least. But you would maybe orient yourself differently. Yeah, as I say, upside down, up would be down, etc. But where you kind of switch what is what within that system. So I'm inclined to say that it would still be Euclidean in that sense. It's the system of this axis in three dimensions. Yeah. Yeah.
No, we have one last question, and then that's it.
Thank you for the presentation. This was very exciting, I think. And did you take into account also the ontological pathologies? For example, people who cannot perceive the objects on the left.
Sorry, the ontological what?
Pathologies. Pathologies?
Pathology?
Yes. Pathologies.
Oh, pathology.
Pathology.
Oh, sorry. Sorry. Ontological pathologies like...
Yes, like people that cannot perceive objects on the left.
Oh, yeah, these kinds of examples. Actually, I'm in neuroscience. I'm collaborating with the person who does these experiments with people. So, the point again is that the person, I mean, you are devoid of feeling that, let's say, the left hand, for instance, but you're not devoid of understanding, for instance, that there is something opposite to the right hand that you feel. But of course, if you are totally devoid of the other side, of course, that would affect the capacity for orientation de facto, at least. So, yeah, okay. The short question is yes, it would affect the way you navigate or orient yourself. Okay. Thank you very much, Anita. Thank you.